Hi, and welcome to Patch a Day 33. I'm actually only going to do one this week, so Patch a Day is becoming something of a misnomer. All right, I'm going to start by, yes, today I am going to do something with FFT feedback, so feedback within an FFT. Yes, several ways of doing it, and I'll run through several of them right here and right now. So I'm going to start off by opening up something to play back a file. I've done this about 1,000 times before with an SF play and a message saying something along the lines of, even though it pains me to do it, I'm going to open cherokee.aif, with another comma, and then loop with the space 1, and then 1 to start that playing back. Again, we hook this up to our SF play. We can bring in one of the EasyDAC objects just to verify that yes, indeed, this thing is playing. When we click the message, yes, I've done that altogether too many times before. So pretty much everything we're going to do is inside the PFFT. So let's just make a new patcher for the PFFT and put in, as we always do for PFFT, FFT in. Actually, I guess we don't always have to. And an argument saying which FFT inlet we want it to go in, which is 1. And an FFT out. Again, that's with a T. With a 1, argument 1 for the which FFT outlet. Okay, so the simplest way you would think to do some kind of FFT feedback would be with tap in and tap out. So let's just try that. Tap in, we give it an argument of, I don't know, doesn't matter, I've got plenty of RAM. Give it 1,000 and a tap out, again, of 1,000. I mean, whatever it is. Right. I'll give it 100, sure. Okay, and then we can put this together like so, and then put some kind of multiplier value on it, and this should be feedback. Right, so this goes in here, this goes in there, and then we can take our reel and do the feedback on the reel, and we can do the same, just duplicate that all, and that was selecting it and dragging it over, selecting it and dragging it, holding the Option key or the Alt key. All right, so that should be FFT feedback, right? All right, let's just see how this thing sounds. If we save this as, let's see, let's just go patch a day. I'll save it in a folder called garbage. I'll call this FFT feed, no, FFT FB. Perfect. And then we can create create a PFFT here, new PFFT with the FFT FB, which was the name of my file that I just saved. I can give it an argument for the size of the FFT analysis and the number of overlaps, which is 4. Again, it didn't open this. Max is telling me no patch your FFT feed FB. So I'll save it in that folder, again the same folder, and this is my FFT FB. All right. Now I can recreate this, and lo and behold, there comes the outlet that I wanted. I'll just try putting this in here, see how it sounds. Okay, that's kind of something random, is kind of what I expected, because the feedback is not happening at a duration or a length that coincides with the size of the FFT. So I suppose we could do something to make it coincide with the FFT, which we could use FFT info. And when we start the DAC, we get, for example, the FFT frame size, which is in samples, and this here, of course, is in milliseconds. So one logical answer to that would be to create, to make something that did samps to milliseconds, samps to ms is the object with the tilde, and we can stick that in there and stick this in here and in here for the delay times, and we can see how that sounds. I can't hear it very clearly on here. But if we turn up the feedback, which we'll need something else over here, let's make a new RFB amount. Hello? Okay, FB. That's because I created this somewhere else already in a patcher that's open. So I'll call it FB FB yo. And we'll connect that to the multiplier just to change the amount of feedback. So it's already getting messy. All right, good. Copy that receive so I don't have to remember its name and paste it out here. And put a F for float on that thing so I can change it. Okay, so it didn't update this, or did I not save it? I didn't save it, that's why. Okay, so that proves one thing that I was looking to prove, is that the FFT, the tap in and tap out are not accurate, or not, well, not sample accurate enough to make that feedback work. But I've used this effect in several different contexts where you basically change this tap in and tap out, change these tap out values to create this kind of sliding, noisy strangeness. But that's just one of the effects that you can get. So obviously some kind of multiplier on this will give you like the ratio of the size of the FFT roughly, but you'll never get it to actually feed back in the right place. So to get it to feed back in the right place, we're going to need a couple of other things, a couple of improvements over inside here, where we can look, for example, instead of, well, let's just poke the FFT data into a buffer and read that buffer back. So I'm going to make a new buffer, and I'll call it, I'm going to run out of names for things in my head here, FBme. Yeah, that's what I just wrote, FBme. All right, and I guess I'll need some kind of duration, so I guess 200 milliseconds is probably quite enough, and a number of channels too, one for the real, one for the imaginary. It's probably something better to do with this with using, what am I thinking? Oh yeah, using the magnitude instead, using a Carter pole, maybe. I don't know. I haven't played with it much. All right, I'm just going to obliterate some of this, so if you wanted to save that as something else, go ahead. So I'm going to go and read and write to that buffer while I'm doing my FFT-ness with an index tilde. Obviously I need a name, FBme, and which channel on that FBme thing. And I'm going to use this bin index to read from that buffer. I don't need this FFT info anymore either. And I can also do the same on the other side. All right. So this is the index to read it from. We're going to be poking that same thing in as well. So we can poke tilde. Uh-oh. All right, so poke tilde, the same buffer, FBme, and which channel on that FFT. Again, so we're going to use the index to poke, we're going to also have the, well, we're going to have the imaginary in there as well. We're going to take the real and poke it into that, and we're going to take the imaginary and poke it into this side as well. But first we're going to use some kind of multiply for this, which we're reading back, and add it with the real and imaginary that's coming in live. So that would mean at least plus, so new plus object plus tilde. So this plus this, and we probably also want some kind of multiply to determine how much of our old signal is being fed back into the new signal. All right, then we go is sure, we'll do it like that, and this will be this plus, and I guess I got rid of that receive when I shouldn't have, so I can hit a new what was it called, RFB yo as my multiply for how much that works actually, but I'll put it in the out inlet that looks right. And this all goes into here, and I'll do the same on the other side with the imaginary, and we'll end up with something like this and something like this, and we'll take, there's nowhere for this FFT out to come from at the moment, so we'll take it from this index right here. All right, looks good. Let's try saving that and see what happens over on the other side. Alright, so it's really, the effect sounds a lot like just a huge bank of comb filters, which is really what it is. Other things we could do, let's just see if we, for example, here's an idea that we could, instead of just having all of the bins in the FFT feed back equally, we could change how much they feed back in each, how much each bin feeds back. So we could do, for example, make a new object. Actually, let's make a new buffer, and we'll call this buffer table feedback. And again, we'll give it a duration. I don't care too much, to 100 milliseconds, sure. And we're going to use peak, which is the kind of control input side of the, similar to poke tilde, but this one uses control values instead of signal values. So there's our peak, and I'm going to use a table. And for the moment, I'll use a iTable. I don't know what it looks like on the palette, but iTable will bring one up. And I'm going to make it so I can draw values in here and have them peak, pack into the peak. So I'm going to make a new pack, and I'm going to have an index and a value, and that's going to be a sample value. So it wants to probably be somewhere between 0 and 1, or 0 and something, but it's going to be a float. So pack 0 without float and pack 0 with float. And we go to this thing where we're going to, every time this thing's edited, it puts a bang out here. And you can even see that's what it says, even though it's a bit obscured. So I'm going to get the message every time I edit the table. I'm going to get it to dump its outlets, its output out here. And every time I dump it, I'm going to run through a counter. So I'll make a counter that goes from 0 to 127. So just counter 127. And I guess to keep the timing straight, I'll go trigger bang I, so that it triggers out the integer first, that's the value stored in the table, and then a bang to bang that counter along. And I'm going to divide by 127 so that the values in my table are just between 0 and 1. Okay, so this is all ready to hook up like so. And we can already see that if we draw a shape in that table, we should get the same shape in our buffer here. And maybe my buffer's a bit big to really show that clearly. Okay, that's really great. But now we can hook up, we can read this using the index in this FFT back here in our PFFT patcher. And I'm going to use, let me just look at this again so I remember what I'm doing. Yes, I'm going to use an index on this buffer that I've called table FB. So new what index? Yes, thank you. Index table FB. I guess we'll read that index over here again, and I can use that as the multiplier down here. All right. That should work, I guess. Let's just see how that sounds. Save. It should automatically save in bring it up in here. So yeah, now you have control over which frequencies or which of those comb filters, if you like to think of it that way, is the strongest, or its relative level. There's other things you can do. You can do like a million things here. Like for example, let's just try sticking in a cycle tilde with a low frequency of like 0.2, an LFO if you like. We could try sticking that in to our multiplier instead of the index. So you get some kind of moving multiplier going on. Save that, see what that sounds like. All right, so that's pretty much it. You can just play around. There's about probably a 1,000 or more possibilities of dealing with this stuff, and hopefully I can get more than one of these patch-a-days done this week, and I'll see you in 34. Bye.